Good morning. My name is Ronith Anshan, and along with my teammates Chinmay Agrawal and Shoria Kumar, we created SurgiScan, securing surgeries one tool at a time for the betterment of patient safety. Our solution was intended to tackle the issue of retained surgical instruments, incidents in which surgeons leave instruments and/or foreign objects within a patient's body during surgery. While this issue may initially seem incredibly rare, there are around 4,000 cases a year, or roughly 1 in 18,000 inpatient surgeries resulting in retained foreign objects, translating to almost every single large hospital having at least one incident a year. These cases typically result in very public, damaging, and expensive lawsuits by the affected patient against the hospital, costing an average payout of $350,000 per case. Retained surgical instruments are a problem for everyone: hospitals, care providers, and patients alike. On the hospital side, hospitals lose trust within their respective communities and suffer severe financial loss due to lawsuits. On the patient end, many of these cases result in great suffering due to pain and infection caused by these retained objects, leading to a dramatic loss of quality of life and, in certain cases, even death. Care providers are also affected through additional stress being loaded on top of their already stressed workloads.
So currently, the solutions to tackle this issue are RFID-enabled sponges, scanning items with barcodes, scrub techs doing pre-surgical and pre-closing counts of items, and the safety checklist running through basic information such as who and what is being operated. Studies show that, despite this, it fails to detect 62% of retained objects. This is due to certain surgeries that run for 18 hours, changes of staff, simple arithmetic human error, overworked and fatigued healthcare workers, miscommunication, and situations such as trauma surgery making it easy to miss an item. All these potential causes lead to inaccurate counts, which end up costing the patients their health, hospitals money, and healthcare workers their career. We realized that if we wanted to minimize the amount of errors that occur within retaining foreign objects, we could have an extra quote-unquote set of eyes from a trained computer vision model, making the OR staff job a lot easier and, more importantly, ensuring the safety of the patient. The solution that we came up with is a computer object detection model based off of YOLO version 5 that can identify when a surgical tool enters or leaves a surgical frame. And in a real scenario, this surgical frame would be positioned over a procedure and would create a dictionary of items and their quantity that exists within the frame. Obviously, for this hackathon, we did not have access to the proper surgical tools, such as a surgical sponge or scalpels to train our model off of. So instead, we used and trained our model off of utensils to mimic surgical instruments. To train the model, my teammates and I self-made a data set of 170 images of forks, knives, and spoons, and manually annotated them by the class of the type of silverware, so the model would be able to detect the different utensils on camera. In order to better demonstrate this, I'll run and go over the live demo of our script. So if I go here and I enable the script, so as you can see, this is what pops up, and the rectangular green box is where the procedure will be positioned in. And with my so-called medical instruments here, I have my knife, my fork, my spoon, and my fork. If I were to position it within the frame, you would see that the model would be able to detect the fork, and on the top left, it would also create a dictionary of how many forks are present within the frame. If I were to remove it, it would also remove it. And this works for every single tool that we have. So for spoon, it would create one spoon. If I were to put a fork in there as well, it would be able to differentiate those two. And if we were to put all three, it'd be able to identify all three of those. So you may notice that there might also be some discrepancies within the count or the tool. And this is due to our data set being relatively small for training, as training is a process that takes hours. If we wanted to improve the accuracy of this, we would just need to feed in more data and pictures for higher accuracy. And in a real scenario, we would not be using, obviously, knives, spoons, and forks, but rather scalpels, surgical sponges, and other medical tools to ensure that all foreign objects are retained after a procedure.
There are many reasons why this solution is viable for hospitals. With the current rise in patient distrust in medical professionals, an extra set of computer vision eyes that tracks the count of items being placed within the open field, such as small sponges and clamps, provides an extra level of security amongst the checklists and safety procedures already in place. This camera does not take away a scrub technician's job, but rather makes it easier when the overworked, fatigued staff may not be at peak performance when long surgeries take place. With the use of a 3D depth perception camera, the model has access to a clear bird's eye view of the open field within patients. The model also gets better as time passes due to improvements in object detection and classification, with millions of surgeries taking place across the globe every year as data. The benefactors of this solution involve many. Hospitals, as they won't be jeopardized in litigation battles that cost them their reputation, potential loss of staff, and loss in unearned revenue due to negative publication from media. Healthcare workers who are assisted in situations where making simple human errors is also easy and benefit from not having to worry about lawsuits against surgeons who risk losing their medical practice license and even higher insurance costs. But most importantly, it provides the patients a more incredible surgery experience due to the additional safety feature, enabling a greater sense of trust in an age where distrust in the people saving their lives is significantly on the rise. For future implication, this device's ability to make patient safety even safer, we can expand the ability to recognize the left and right sides of limbs and other anatomical areas to prevent mispractice in situations where the wrong hand or the wrong leg was operated on. It could have audio-enabled recognition to make sure that pre-surgical checklists take place, and with larger data set to train on, the recognition of other medical devices and surgical tools can be integrated along with sterilization verification to make sure that unsanitary surgical conditions never take place. It can also go beyond the checks and assist, for example, cardiothoracic surgeons who experience cases of blood vessel cuts more often with some fluid dynamics programming. Overall, our video-enabled situation to prevent the miscount of surgical items left in patient bodies by making the OR staff's job easier when hard situations make missing an item easy. It can allow surgeons to backtrack and locate exactly when and where certain items were left, and help confirm the post-surgical count of commonly missed items, such as small sponges and clamps. Our solutions benefit hospitals, the OR team, and most importantly, the patient by preventing pains and second surgical revisions to remove items that should have never been left behind in the first place. With our camera-enabled technology, never events such as retained surgical items, RSIs, can be prevented. Its implementation can go towards ensuring correct body parts are being operated on, proper checklists take place, and even check bleeds. SurgiScan is an innovative solution to this never event, which can save litigation battles and, of course, lives. Thank you.